All right, y'all, like I said, this will be 7.5. Analyzing graphs. Quadratic functions. And the main thing we're going to be looking at is what we call a vertex. So let me draw a graph real quick. So this point I'm making is going to be at 2, -3. And then I'm just going to draw a parabola off of it. All right, so the point we're looking at today is this minimum point here. We're going to call that the vertex. All right, so on this parabola, the vertex is the point at which the parabola goes from decreasing to increasing, or from increasing to decreasing. So notice on this one, it's decreasing, going downhill left to right. At the vertex, it starts going uphill or increasing. And then it can go from increasing to decreasing if my parabola is upside down. So if it's upside down, it would increase, hit the vertex, and then start decreasing. So there's a few things about this vertex point here. If we draw an imaginary vertical line, through that vertex, let me let one in real quick. If we draw an imaginary vertical line through the vertex, it cuts the parabola in half. So we call this line, we call that the axis of symmetry. And like I said, it's an imaginary vertical line through the vertex of the parabola. And it equals the x value equal to some number. So for this example, if I was going to give the axis of symmetry as an equation, it would be x equals 2, because that's the x value that my vertical line is going through. So it's always equal to the x value of the vertex. So we'll put that equals the x value of the vertex. So that's what we get from the x coordinate of this vertex. The y coordinate here, which is -3 for my example, the y coordinate is with what we call the minimum or maximum value. So the minimum or maximum value is equal to the y coordinate of the vertex. Now, to determine whether it's a minimum or maximum, we look at the x squared term. If the x squared term is positive, then we have a minimum. And if the x squared term is negative, then we have a maximum. So remember, the x squared graphs, if the x squared term is positive, you'll get a U-shaped parabola. But if that x squared term is negative, such as a negative x squared, remember that reflects the parabola over and it becomes a maximum, okay? All right, so there are a few more things we need to know before I hit the formula. So let me scoot that back up. Increasing intervals. So when they talk about increasing intervals, they want to know the x values where the graph is going uphill from left to right. Okay, so they're always given as intervals, and they'll go from the first x coordinate to the last x coordinate. We got decreasing intervals. And those will be the x values where the graph is going downhill from left to right. And they'll also be in the form of interval notation, okay? So the x coordinate where it starts going downhill to the x coordinate where the graph stops going downhill. So since we're looking at parabolas, these are the only intervals we're worried about. Later on, when we do section 6.8, we'll look at what we call constant intervals. And that's where it looks like a horizontal line going left to right. But y'all, for this section, we only need to know these types of intervals. So let me give you what we call the vertex formula. So the vertex of a parabola can be given by, now remember, the vertex is the point, so it has to be given as an ordered pair. The X value of the vertex we'll find by doing negative B over 2A. To find the Y value, we find F of negative B over 2A. So basically, we find the X value and then plug that F value back into our function, get the Y value. So remember, we're looking at the quadratic. So those are given by this formula. So negative B over 2A would be the X term is B. A is the X squared term, sort of like the quadratic formula. And if you remember that quadratic formula, that negative B over 2A is in the beginning of that quad, okay? So the trick is finding the vertex. Once I find the vertex, I can then figure out what the axis of symmetry is, because it's going to be equal to the X value. I can then find the minimum or maximum value of the parabola because of the Y value. Now, remember, if this A term is positive, it's a minimum. If the A term is negative, it makes it flip over and become a maximum. So let's play with one of these and sort of see what we got going on. So they're giving me the function f of x equals x squared minus 14x plus 40. A, they want me to find the vertex. B, find an equation for the axis of symmetry. C, determine if it has a minimum or maximum and the value. So min or max and value. And then let's see, D, they'll want us to graph it. And remember, since these are parabolas, when you graph it, you'll have to use the 3-point quadratic tool, okay? All right, so let's see what A, B, and C is. For this equation, A will be 1 since there's no number. B will be negative 14. C will be a positive 40. Once we find our vertex, we got everything we need. So to get the X value, we're going to put in negative B over 2A. So just like in the quad, that negative in front of the B, its only purpose is to change the sign of what B is in the equation. So this will give me a negative times negative 14 over 2 times my A, which was 1. All right, y'all, so let's see, that's going to give me a positive 14 over 2, which will give me 7. So far, I know the X value of the vertex will be 7. To get that Y value, I take this 7 and put it back into the function. So we find f of 7, which will equal 7 squared minus 14 times 7 plus 40. All right, so let's see, 7 squared is 49. 14 times 7, that gives me 98. So that'll be 49 minus 98 plus 40. Hey, also, here we go. 49 minus 98 is a negative 49. Negative 49 plus 40 gives me a negative 9. So I now know the y value of this vertex is negative 9. All right, so remember, the axis of symmetry is equal to the x value. So since my x value is 7, the equation for the axis of symmetry will be x equals 7. So if I drew me a vertical line straight through that x value at 7, it would cut my parabola in half. I know the min or max value, that's the negative 9. But on this parabola, y'all, do I have a minimum or maximum? What do y'all think? And all we're going to look at is this A here. So remember, I said if A was positive, you would have a minimum. Oh, I didn't see my chat. Let me get my chat pulled up. So y'all both got that. And so it is definitely a minimum. And then the minimum value would be the negative 9. Now we'll say this. When you're graphing this in MATLAB, I usually put this equation in my calculator to get 2 other points. Now, you could do the quadratic formula to get 2 other points, but we know what the vertex is, so that'll be the first point of the plot. So y'all, I'm just going to go to y equals here. Let me turn this thing off. Now I'm just going to put in my equation, which was x squared minus 14x. Whoops. X squared minus 14x plus 40. All righty. Now, I will say this. In MATLAB, we have to plot the vertex first. So you'll go over 7. We'll go right 7 and down 9. That's going to be our vertex. Now, in MATLAB, you have to have 2 more points, 1 on each side. So I'm going to go to the table by hitting second graph. And I'm going to get sort of close in the x's to where the vertex was. So remember, that was at 7, negative 9. So there's my 7, negative 9. And notice, negative 9 is the smallest number here. So that definitely lets you know that's my minimum. Now in MATLAB, I would probably grab 8, negative 8. So I would go over to 8, down to negative 8. And then I would probably go to the other side and do 6, negative 8. So go to 6, negative 8. Once you plot that second point, MATLAB is going to draw your parabola. And if you want to see the graph, just hit graph, and there it is. So I guess I opened mine up too wide. It should have been a little more narrow, it looks like. But the main thing is, vertex has to be the first point you plot, okay? All right, so let's go on. So y'all are not too bad once you find that vertex for it. So the same thing, I'm going to find the vertex. axis of symmetry. Maximum or minimum value. And then you would graph it. They're giving us f of x equals 2x squared plus 10x plus 15. So we find A, B, and C again. A is 2, B is 10, C is 15. And my formula is negative B divided by 2A for the X, F of negative B over 2A for the Y value. So let's get the X. Negative B divided by 2A will equal negative 10 over 2 times 2. So it looks like this is the only one. When y'all do number 3, it will have fractions for the vertex. This is the only one that did that. Because I get a negative 10 over 4. And let's see, that reduces to what? A negative 5/2. So I know my vertex X value is going to be negative 5/2. So to get the Y value, I'm going to plug negative 5/2 in for those X's. All right, y'all, so that'll give us f of a negative 5/2. That'll equal 2 times negative 5/2 squared plus 10 times the negative 5/2 plus 15. All right, so I'm going to start with the exponent. And the only thing the exponent affects is this fraction. So bring down that 2. When you square a fraction, top times top, bottom times bottom. So negative 5 times negative 5 gives you a positive 25. 2 times 2 gives you a positive 4. And then I'm just bringing everything else down. So on that step, all I did was square my fraction. Now, before I can add, I'm going to multiply 2 times 25/4, 10 times the negative 5/2. And remember, if you want to, put a 1 under these numbers. Because remember, fractions is top times top, bottom times bottom. So 2 times 25 gives me 50. 1 times 4 gives me 4. Plus here, 10 times negative 5 is a negative 50. 1 times 2 is 2. And then at the end, I'll bring down my 15. All right, y'all. So if we're going to be able to add all these, and I'm going to make the 15 look like a fraction by putting a 1 under it. But if we're going to add all these, we need a common denominator. And for these fractions, the smallest common denominator would be a 4. So since this one already has a 4, I'm not changing it. So I'm going to bring down my 50 over 4. Now this second one's going to be negative, so I'm just going to make that a negative. To turn 50 halves into a 4 on the bottom, I would multiply the bottom by 2, which means I got to multiply the top by 2. So that'll give me 50 times 2 is 100. 2 times 2 is 4. To turn the 1 into a 4, I have to multiply by 4. which means the top has to multiply by 4. So 15 times 4 will give me 60. 1 times 4 is 4. So now we have a common denominator. We can add these fractions together. So remember, the bottom's going to stay at 4 at this point. All the adding and subtracting get done on the top. 50 minus 100 is negative 50. Negative 50 plus 60 is 10. Now I got 10 over 4. I can reduce that now to my final answer. Divide 2's out of both of those. And that gives me a positive 5/2. So my y value is a positive 5/2. All right, so I know the vertex, the axis of symmetry. That's equal to the x values, but that is going to be x equals a negative 5/2. Then we'll have to figure out if we have a min or max. And then we'll put that value. So y'all, I ask y'all, on this graph, will we have a minimum or maximum? And y'all remember, you're looking at this. Since A is 2, what's that going to give me? So yeah, it's going to be a minimum again. Good job. Anytime the A is positive, we're always going to have our minimums. Now, since it's a minimum, the minimum value was the y value, which was 5/2. So let me tell you what the graph will do on this. I'm gonna put a picture here. In MATLAB, they'll have it in halves instead of ones. So it'll be like 1/2, 1, 1.5, 2, and so on. So I got to plot my vertex first. So negative 5/2. Since these are in halves, all you got to do is go left 5. So 1, 2, 3, 4. That'll be negative 5/2. And then 5/2 positive will be 1/2, 1, 1.5, 2, 2.5. So when it's separated in the halves, all you got to do is move what the top number's saying on each of these clicks, okay? All right, so that would be my vertex. Now, if I want some more points, remember, I'm just going to go to y equals and put in 2x squared plus 10x plus 15. And I'm going to go to the table. So let me get up here. Now, y'all, I might show y'all a trick on this. Well, no, I won't worry about that. Yeah, let me show you a trick. You see above the window, it says table set. If I hit second window and go down to here where it says that triangle table, that triangle means delta, which means the change in the table. So at the moment, it's going by ones. But what if I did 1 divided by 2? I'm going to set it up in halves, just like my question was dealing with halves. So now when I go back to my table, second graph, the numbers are in halves. And here at negative 2.5, I got 2.5, which was my vertex. So now that I know where the vertex is, I can get 1 point on either side. So I'm going to plot negative 3, 3. So over here at negative 3, I would go up 3. My other point on the other side, I'm going to do negative 2, 3. So at negative 2, go up 3. And y'all, at that point, I know what my graph is going to look like. And when I hit graph on the calculator, there you go. So that little graph is coming up over here on that left side. Now, if you don't want to keep the calculator in halves, go back to your second window. So second window for the table set, and go down to the triangle table where it says 0.5, clear that out and put a 1 back in there. Once you put a 1 back in there, the table then goes back to going by ones. So anytime you have fractions, you can set it up to give you values by halves instead of by ones, okay? All righty. Question on that. All right, y'all, how about this? Negative x squared minus 4x plus 2. So we got our formula here. So let's find our x value. First, we got to figure out A, B, and C. All right, so that's a negative x squared. So that means A will now be a -1. B will be a -4. C will be a +2. All right, so x coordinate, -b over 2a equals the negative times -4 over 2 times the -1. So y'all look at this, the double negatives on top make that a +4. On the bottom, you still got a negative, so 2 times -1 is -2. 4 divided by -2 gives us an x value of -2. So my vertex will definitely have an x value of -2. To find the y value, we put -2 into this function. So we're finding f of -2. Now y'all be careful on this because you got a lot of negatives. That negative, you have to write here. My x value is a -2, and I'm going to square that. -4 times -2 plus 2. So y'all, when you got a negative in front of your x's and your x's are negative, that's going to give you this type of situation. Now, remember, order of operations. So you cannot multiply the negatives yet. So bring down this negative and work the exponent. The exponent only affects the -2 in the parentheses. And remember, -2 times -2 gives me a +4. And then I'm just going to bring everything else down. So when you got a negative in front of an x squared, it stays negative, okay? Because any sign that's in here will become positive. So that outside negative will keep that negative. So bring down that -4. Right here, -4 times -2 is a +8. And then bring down my +2. Now y'all, I'll show y'all a trick. When you're at this point where you're adding, the second number is always twice as big as the first number and opposite in sign. Look up here. Up here we had -50 halves and 50 fourths. Well, if you had a common denominator, that gave you -100/4, which was twice as big as 50/4, and one was positive, one was negative. You'll see that pattern every time on these. All right, so here we go. -4 and 8 give me +4. 4 plus 2 give me 6. So I now know the vertex is -2, 6. All righty, so now what do we need? The axis of symmetry. So I'll let y'all tell me the axis of symmetry. So I got an x equals -2, perfect. Now, making sure you put that x equals on that, so good job. Because if you just put -2, it will mark that wrong. You gotta have the whole equation. So how about this one? Do I have a minimum or a maximum? So good job, y'all. Maximum for sure, because my a is negative. And then the minimum or maximum value is? There you go. So y'all, these ain't too bad. The trick is just getting this formula worked out to get that vertex point, okay? So remember on this one, you would plot -2, 6 first, and then find 2 other points, and it will draw your parabola for you. All right, also. Now, knowing what y'all know about vertexes now, this is a true or false. So true or false for y'all. The function f of x equals 6x squared plus 6x plus 1 has a maximum value. So y'all, is that true or false? And I'm gonna guide y'all to, so y'all saying false, good job, because guess what? 6 is positive, and since 6 is positive, this thing would actually have a minimum value. So good job. That is definitely a false. All right, so how about this one? The graph h of x equals x plus 2 squared can be obtained by translating the graph of h of x equals x squared right 2 units. So this sort of goes back to 7.2 when we were moving those graphs around. When I'm inside those parentheses, that's horizontal translations. But is that +2 moving me to the right, or is that +2 moving me to the left? Oh, I'm gonna get y'all on that one, ain't I? Remember, on horizontal though, inside the parentheses, they were sort of backwards what you would think. You would think adding would move it right, but remember, when you added to the x's inside the parentheses, this actually moves it to the left. So this one would have to be false also. Now, at the end, that does go up or down like it says, plus is up, minus is down, but y'all remember, on these translations for horizontal, positive moves me left, negative moves me right, okay? All right, so I got one more for y'all to redeem yourselves on. The axis of symmetry of the function f of x equals -9 times x plus 8 squared plus 4 is at x equals -8. So would the axis of symmetry be at the x value of -8? So remember, what did the +8? Oh, good job. Since the +8 is positive, it moves me to the left. And if it moves me to the left 8 units, I will definitely be at x equals -8. So that one is actually true. And y'all, that's all you really got to look at on that is what's inside the parentheses. All right, y'all, so let me get my next ones out. Let's see. I'm gonna put my paper over real quick. All right, so they want a lot on this one. So for these examples, we're going to find the vertex, maximum or minimum value, find a range, and then find intervals of increasing and decreasing. So our function is going to be f of x equals x squared minus 10x plus 24. But y'all, I'll tell you a trick on these. Increasing and decreasing intervals will also depend on the x value of the vertex. And they'll either be coming in from -infinity or headed out towards positive infinity. So first, let's get the vertex. So I'm gonna get my vertex. I'm gonna get my min or max value. I'll find the range. Remember, range is my y values. I'll find my increasing and or decreasing. All right, so A looks like 1. B is -10. C is positive 24. So we need that vertex, and then all of this is not bad. X will equal -b over 2a, which will equal -10 over 2 times 1. All right, y'all, so that's gonna give me a positive 10 on top, positive 2 on bottom, which divides to give me 5. So I know my vertex will have a x value of 5. All right, so yeah, just making sure they don't want a line of symmetry on this one. Now the y value would be f of 5. F of 5 will equal 5 squared minus 10 times 5 plus 24. So remember, 5 squared is 25. So I know the next number will be double that and opposite in sign. So that's going to be what, a -50 and then plus my 24. And y'all, that always does that. If I know the first one, I can change the sign and double it to get the second number. So let's see, 25 minus 50 is a -25. -25 plus 24 is a -1. So we now know the y value is -1. So if I was going to draw that, let me see. So at 5, -1 right here is my vertex. So the question would be, is this vertex going to be a minimum or maximum? So minimum, good job. It's definitely a minimum. Because remember, A is positive there. Minimum value would be -1. So we've got a parameter doing something like this. It's a minimum over here at 5, -1. Remember, the range is the y values. Well, we know the smallest y value, right? We know the smallest y value is -1. So you come over here, and since -1 is included in the range, you gotta use square brackets. So we use a square bracket on the range, remember? So from -1, here's my y values going up and up. Where they heading to? Y'all think about this. The numbers are getting larger and larger as I go up. So they're headed towards positive infinity. So my range will start at -1 and heads towards infinity in the y direction. Remember, infinity always has curve brackets. And y'all look at this. We're looking for the increase in intervals, and those are x values. And they're always in interval notation with curvy parentheses. The vertex value of 5 is the point where it changes from one to the other. This left side is decreasing because it's going downhill. Then at this x value of 5, my graph is increasing as I go out my x's. So y'all, where are these x's heading forward in that direction? So they are definitely headed towards positive infinity. There you go. So from 5 to positive infinity, it's increasing. This left side is decreasing. So remember, you got to read them left to right. So as you're coming in from these x's, where are they coming in from? So negative infinity. So that would be negative infinity. Good job. And then they hit 5. There you go. So when you're doing increase and decrease, and the vertex value, that is the x value, is the point where they're switching. So you're going to go from negative infinity to that number, from that number to infinity. Okay. All right, that's all they wanted on that. So let's try another one like that to see how y'all do on it. Well, let me see. Yeah, this one is another fraction looking one, I think. So let me get ready. So we're going to do the same thing for this one. F of x equals -8x squared minus 24x plus 9. We're going to find our vertex, min or max, and the value. or range. Increasing and decreasing. And y'all, I'll tell you the biggest mistakes I get on these is people use the range values for increasing and decreasing. Remember, we're only looking at the X values where it's going up and the X values where it's going down. All right, y'all, A is -8. B is -24. C is 9. So I'm gonna get my X coordinate. -b over 2a will equal negative times -24 over 2 times -8. All right, y'all, so let's see, 3 negatives again. So when we're done, this thing will end up negatives. So I get a positive 24 on top, -16 on the bottom. Well, let's see, what numbers can I take out of that? I can take out 4s. Oh, I can even get, those are both divided by 8. So this will make this a negative. 24 divided by 8 is 3. 16 divided by 8 is 2. So this one will have a X value of a -3/2. So to get the Y value, I'm finding F of a -3/2. So that'll be -8 times -3/2 squared minus 24 times -3/2 plus 9. So I'm going to sort of step through this one. Only thing I'm doing on this first step is squaring the fraction. So bring down to -8. And y'all remember, squaring that fraction, top times top, bottom times bottom. So -3 times -3 is a +9. 2 times 2 gives me a 4. And then I'm bringing everybody else down for the moment. All right, so now I'm going to do my multiplying. So put a 1 under the 8 and the 24. -8 over 1 times 9 over 4 gives me a -72 over 4. 2 negatives right here will make that a positive. 24 times 3 is 72 over 2. And then plus my 9. All right, once again, I'm just putting a 1 under that. My least common denominator would be 4 for this. So usually on this problem, the least common denominator will be the largest denominator, okay? Because that's the smallest denominator they all three will go into. So that's already got it. So bring down -72 over 4. Second fraction, 2 times 2 gives you 4 on the bottom. So we got to multiply the top. So that'll give me a positive 144 over 4. And check this out. At this point, this was a -72 over 4. This one's twice as big and different in sign. So 144 is twice as big as 72. Now, to turn this into a 4, multiply the bottom by 4, top by 4, and I get 36 over 4. All right, y'all, so let's add these. -72 over 4, 144 over 4, and 36 over 4. At this point, the bottom will be a 4. So -72 plus 144 give you 72. And then let's see, 72 and 36 give me 108. Oh, y'all, guess what? This one actually divides out. 108 divided by 4 gives me 27. So I know the Y value is going to be 27. So the question, do I have a minimum or maximum? And y'all are looking at that negative. Oh, y'all are hitting it now. Maximum for sure. Definitely a maximum. Because my A is negative. So that means, so -3/2, 20, somewhere up here, this graph is doing like that, because that's a maximum. And y'all, the maximum value was what? 27. Now watch the difference on the range. Because remember, the numbers are coming from down here to that point. So on your range, the numbers are starting where? Negative infinity, good job. And then they go all the way up into Y values until I hit 27. So 27, remember, has to be in brackets. So for the range, if it's a minimum, it'll start at that number, go to positive infinity. If it's a maximum, it'll start at negative infinity and go to that number. All right, so increasing on the left side this time. So on the increasing, there's my line of symmetry. It's increasing from where to where? Oh man, y'all are quick. Negative infinity, perfect. Oh, and then you already got my -3/2. So good job. Keeping them on the x's. So Kara, if that's my increasing, what is my decreasing? So -3/2, positive infinity. Good job. And those ones will always, like I said, that x value will be the point that they go to and the point they start at, okay? All right, so I got one more for y'all, and it's just a little word problem. This is what we would call an application. So we got a toy rocket. A toy rocket is shot into the air from a launching pad. So the launching pad, 7 feet above ground. With an initial velocity of 96 feet per second. So then it says the height in feet for my rocket at any time t seconds after launch is given by the function. So their function is h of t. So this is the height and time is the variable, right? Because the height depends on how long it's been in the air. So the formula is -16 t squared plus 96 t plus 7. So I'll explain what this is. 7 is what we call the y-intercept basically because it started 7 feet above the ground. So you had a little platform and this was 7 feet above the ground and here's your little rocket. 96t, because the height depends on how long it's been going 96 feet per second. So when you multiply the time times the speed, that'll give you a height. Can y'all guess what this negative 16t squared would be? What else might affect my height? So let me ask you this. If you throw something in the air, what makes it come down? There you go, definitely. So this negative t's 16t squared, that's what happens to it due to gravity. And that's why it's negative, because it's wanting to pull me down, okay? Now you don't have to know that. We just got to know how to use this formula. So what they want to know is, how long will it take the rocket to reach the maximum height? And then what is the maximum height? And y'all, tell you what, since this is negative, remember, this is going to make my parabola look like upside down U, and the maximum height and the time to reach the maximum height will be given by that point right there. So remember, since time is the variable, that's going to be like your x. So the x will give you the time. The y value, which is the h of t, is going to be what gives us the height that it reached. So if we can find the x value, we got our time. The y value will give us our height. So for the time, which is my x value, I got to find negative b over 2a. So that'll be a negative times 96 over 2 times negative 16, since that's my a. Now remember, time has to be positive when we're done. And these two negatives will cancel to make this positive. So y'all, I'm going to get a negative 96 over negative 32. Oh, this one actually divides out nice. That gives me what, a positive 3. So I now know it took 3 seconds for my rocket to reach that maximum height. Now we're going to find that maximum height by finding h of 3. So that'll equal negative 16 times 3 squared plus 96 times 3 plus 7. All right, so let me start out with the exponent. So bring down to negative 16. 3 squared would be 9. Then I'm just bringing everything else down. All righty, so let me get some help here. Negative 16 times 9. Whoops. Gives me what, a negative 144? Now, y'all, I don't even have to multiply that because I know the next number will be double that and opposite in sign. And if you double 144, you get a 288. And y'all watch this, 96 times 3, 288. And then bring down plus 7. So the negative 144 plus 288 gives me a positive 144. 144 plus 7 gives me 151, which means my little rocket reached a maximum height of 151 feet. So in vertex form, that would be what, 3 and then 151. But they'll just have you put in the answers, and you don't even have to put the feet in seconds. All you got to do on this one is put in a 3. They already have the seconds, and then 151, and they'll already have the feet. So, starting at 0, I went up to 3 seconds. Rocket's at maximum height. And then probably by the time I hit 6 seconds, because that was the halfway point, right? So 3 more seconds, that little rocket will be back down to about 7 feet in the air. Okay. And it's 7 feet because that's where we started at on the platform. So these are kind of things you can do with these vertex formulas. If you have equations that model stuff being thrown up, and dropping. So y'all, that will be what y'all got for 7.5 homework, okay? Next class, we'll definitely do 6.1 and 6.8. And if I can, we'll knock out 5.4. If not, 5.4, I'll put on the next week, okay? So let's see. Any questions? Y'all, mainly just one formula today. So this vertex formula, but remember, once you find that vertex, you got everything you need for their questions, other than on graphing. And on the graphing part, I would just throw it in my calculator, get my 2 points, and be done with it, okay? Just remember this, when you do graph in MATLAB and you choose that parabola quadratic tool, you gotta plot the vertex first, okay? All righty, y'all, I'm seeing no questions, so let me stop this recording for us.